So here's the actual notes on quadratic formula and discriminant value. On your paper, it just says notes day 6 of graphing, understanding parabolas. Well, yeah, all this is related to parabolas because all of the equations are quadratic equations. So let's understand the first and most important thing of today's lesson, the vocabulary, okay? We need to know when they tell us to find the answers, or when they tell us to find the solutions, or even if they tell us find the X-intercepts, or even if they tell us find the roots, it all means the same thing. It means just solve it. Do we understand that? So all these words mean the same thing. They give you a quadratic equation, maybe like x squared plus 3x minus 4, right? And if they tell you to find the intercepts, you're just going to solve it. If they tell you find the roots, you're just going to solve it. Okay? So here's the first one, first example. It says, so when they ask you to find the x-intercepts, what do we do here? We're going to solve it. And you guys remember on the class opener, how did we find the x-intercepts? We set y equal to 0. So that's what we're going to do. We're going to set y equal to 0, there's 0, equals x squared plus 4x plus 3. Everybody with me? Okay, so now we need to solve it because they're asking us to find the intercepts, so we need to solve it. How do we solve it? We've learned in the previous chapter how to factor quadratic trinomials, especially these easy ones that have the a value of 1. Right? We could do this. Set up the factored form format. Now, of course, it's equal 0. You could put the equal 0 over here if you want. It doesn't matter if you put it on the left side or the right side. But anyhow, let's go back to factoring this. What times what is 3 that if I add together is 4? Super easy. What times what is 3 that if I add together is 4?
3 times 1.
Positive 3 times positive 1. Perfect, right? So we understand that... Let me box this one out or scratch this out. It's kind of bothering me. Let's keep the equal 0 on the other side. So we understand that we've factored it, and now we could split it and solve it. So I really have x plus 3 equals 0, and x plus 1 equals 0. And when I subtract 3, I will get x equals negative 3. When I subtract 1 and subtract 1, I'll get x equals negative 1. I get my two answers. So I have my two answers. Those are my two solutions. Those are my two, what else could I call them? According to the list above, what could I call them besides solutions and answers? Roots. What else? X-intercepts, right? So they could be the answers, they could be the roots, they could be the X-intercepts. Now, when we say X-intercepts, we already know what an X-intercept is, right? We could actually go to a graph of a parabola, and wherever that parabola crosses the x-axis, that will be these two answers, right? I already know my parabola will actually cross at negative 3 and at negative 1. Let's move on here. It says, so when they ask you to find the roots, don't be confused. What the heck? What are they talking about roots? That means just solve it. So let's solve it in a similar way. We're going to set y equal to 0. So we really have the quadratic formula, or the quadratic trinomial equation, x squared minus 2x plus 4 equals 0, and let's solve it. And we could factor this once again. What times what is 4 that if I combine together, oh man, this was a typo. This did not work. Yeah, this did not work. Okay, guys, let's make this change. Go back up here and change that to a 4 right there. Change that to a 4. My bad. I was in a rush creating this worksheet yesterday. Anyhow, if the b value were a 4, which I ask you to please change right now, if the b value were a 4, what could we factor it to? What times what is 4 that if you add together is negative 4? Come on, people. Negative 2 and negative 2, right? Negative 2 times negative 2 is positive 4. If I combine it together, it's negative 4. Now, I could split it and solve, right? Or I could rewrite, since it's an exact binomial and times an exact binomial, I could write that exact binomial squared. Okay? Like I said, I could have split it and solved. If I would have splitted them and solved them, what would my answer be? If I would have splitted them, right here, if I would have taken these and split them and solved, what would my answer be? I'd have x minus 2 equals 0, and I'd have x minus 2 equals 0. If I solve that, what would my answer be? Come on, guys. 2, right? So we already know the answer is 2, right? But I'm doing it this way to show you that I could get rid of the, I could get rid of the square. How could I get rid of the square? How could I get rid of this square right here? By square rooting it, right? And you square root it, right? And when you square root in an equation, the square root and the square, they undo themselves. You will have x minus 2 left over. And whenever you apply a square root, you have to put a plus or minus in front of your answer. But the plus 0 or minus 0 is not going to make a difference, right? Now, we already know that the answer is going to be 2. But let me move forward with this. X minus 2 equals 0. Add 2 here, add 2 there, x equals 2. So we could have splitted, at this point, we could have splitted them and solved and gotten the answer x equals 2. But I did it this way so I could show you where the word roots came from. Okay? So why could we call answers roots? Because on quadratic equations, we could solve by applying a square root. Are you guys with me? Okay, so answers are the same thing as solutions. They're the same thing as roots. They're the same thing as x-intercepts. This next one, when they ask you to find the answer of that quadratic trinomial function, well, you just solve it. They're asking for the answers. Okay, so if we did solve it, x squared minus 7x minus 18, let's put the equal 0 over here instead of the 0 over there. So let's put it on the right side. Let's factor it. What times what is negative 18 that if I add together is negative 7? Come on, people. Negative 9 and 2. Thank you very much. And now, of course, I could split them. X minus 9 equals 0. X plus 2 equals 0. So I get my two answers. X equals what? 9. And x equals what?
2.
Negative 2. So I have my two answers. Factor, split, and solve. We love factoring, especially when you have a quadratic trinomial that has an a value of 1. How about this last one? When they ask you to find the answers. Okay? Let's find the answers to that. What form is that in? Remember the forms from yesterday? What form is that in? Vertex form, right? I already know my vertex is negative 2, positive 9, right? Negative 2, negative 9. And we already know it's opening up. Now, if we actually did graph that parabola with vertex form and we found the x-intercept values, that would be the answers to this equation. But instead of graphing, I'm just going to go with solving x plus 2 squared minus 9. If it equals 0, let's solve this thing. How do I solve it? But before that, remember we want to get the x. We want to get this by itself first. So I want to get rid of the minus 9 by going plus 9 plus 9. I will have x plus 2 squared equals 9. And to get rid of the square, what do? Square root, square root. So I will have x plus 2. And when you apply a square root, you have to put what in front of your answer? Plus or minus in front of that 3, because the square root of 9 is 3. Now x is almost by itself. My final step would be to subtract 2 and subtract 2. And you actually have to rewrite it. X equals negative 2 plus or minus 3. That way you get two answers. You get the negative 2 plus 3, and you also get the negative 2 minus 3. So negative 2 plus 3, that's 1. And negative 2 minus 3, it's negative 5. And those are your two solutions for this quadratic equation that was in vertex form. Okay? Now, let me show you something. So here's the graph of that exact equation that we just solved with algebra. And as you can see, the a value is 1, so it will have a pattern of 1, 1, 2, 4, 3, 9. The vertex is at negative 2, negative 9. So from the origin, negative 2, negative 9. Now this is going by 2s, that's why it's halfway down between the 8 and the 10. So there's a vertex, and it is opening up with the pattern 1, 1, 2, 4, 3, 9. And as you can see, it does cross perfectly between the negative 4 and the negative 6, which means that that's negative 5. That was one solution. and it crosses perfectly over here between the 0 and the 2, which is 1. So the two answers, if you were to graph it, are -5 and +1. Now we found those answers by using algebra. Right here we found the answers +1 and -5. But I just want to show you multiple ways of doing it. So again, this whole video so far is all about understanding that these words all mean the same thing, right? The answers, the solutions, the x-intercepts, the roots. So why do they call it x-intercepts? Because wherever they cross the x-axis, those are your answers. Why do they call it roots? Because sometimes we have to apply square roots to find the answers, algebraically. Let's go up here. But what if they asked you to solve something that's simply not factorable? Like this guy. X squared minus 7x minus 6 equals 0. And you're probably thinking, oh, let's factor it, right? But when you think about it, what times what is -6? That if you add together, you combine together is -7. It doesn't exist. It doesn't happen. All right, it doesn't work. This is where we need the quadratic formula. Okay? And I'm asking you right now, please memorize this formula. This one right here. X equals -b plus or minus the square root of b squared minus 4ac divided by 2a. That's right. I have it memorized. I can say it in Spanish too. X igual a negativo b más o menos la raíz cuadrada de b cuadrado menos 4ac dividido por 2a. Right? Japanese? No, I'm just kidding. I don't. Sorry. But anyway, you have to have this memorized. All right. Some people memorize this with the story, like there was this sad bee and wasn't too sure if they were going to go to a radical party. I don't know, something ridiculous. If stories work for you and you know that story, great. I just say memorize it, okay? Look at it, stare at it, write it over and over, say it over and over, memorize it, okay? Anyhow, guys, this is the answer to all your quadratic equations. Literally, this is the answer. No matter what quadratic equation you have, you could plug in the A, the B, and the C right in there, and it'll get you the answers, even if it's not factorable. Even if your answers are imaginary, this quadratic formula will get you those imaginary answers. All right? So technically, this formula is all you really need to know when it comes to solving quadratic equations. Let me show you. How's this going to work? Now, just like before, I say plug in your values into parentheses. So here's my equation, but I'm going to replace the letters with parentheses. And once I do that, I then identify my A value, which is 1, my B value, which is -7, and my C value, which is -6. Oh yeah, you guys want to see something cool? You guys remember the Vertex Formula? What was the Vertex Formula on standard form equations? X equals what? Check this out. X equals -b over 2a. The Vertex Formula is actually within the quadratic formula. All right, you guys don't think it's that cool, but anyway, let's plug in the B value of -7 right in there. Let's plug in the B value of -7 right in there. Let's plug in the A value of 1 right in there, the C value of -6 right in there, the A value of 1 right down there. Now, when we first plug it in, we have to, you could always start by changing the minus to plus, that's easy. But we have to work with the inside of the radical. This is called the discriminant value, okay, the discriminant. The b squared minus 4ac is called the discriminant. We're going to have to memorize that word also and know what we're talking about when I say look at the discriminant. It's the b squared minus 4ac part of the quadratic formula, this part right here. So let's start with the discriminant. -7 squared minus 4 times something. We're going to go with exponents first. What is -7 squared? 49. Positive 49, because -7 times -7 is positive 49. Now what is, let's call this a -4. What's -4 times 1? -4. What's -4 times -6?
24.
Positive 24. So we're going to put a positive, a plus sign, and a 24. Now keep in mind that that's still the discriminant value inside the square root. And we still have a positive 7 out here. And on the bottom, we might as well do the 2 times 1. 2 times 1 is 2. So there's our slightly simplified expression so far. But now let's actually add 49 plus 24. What do we get? 73, right? Yay? Okay, so we have 7 plus or minus the square root of 73 over 2. Now, let's look at the 73 and think about it. Could I break down 73 with multiplication to get a perfect square number? The answer is no, right? 4 doesn't work. 2 doesn't work. 9 doesn't work. So that's it. We're done. This is your answer. This right here is your answer. Now, some teachers and some classes might ask for a decimal approximation. Like, let's say I told you, give me a decimal approximation of where your parabola that opens up crosses the x-axis. Then you could do on a calculator 7 plus the square root of 73, and then divide it by 2, and it'll give you a decimal value, which will tell you where it crosses the actual x location. All right? And then go back and do 7 minus the square root of 73, and then divide that answer by 2, and that'll give you a different location on the x-axis of where it crosses. But when they ask you to solve, they want your answer. There it is, those 2 answers. And there was no simplification required like we did on the class opener, but many times you will have something in here like the square root of 24, or maybe the square root of 50, and you have to actually break that down. 50 would break down to 25 times 2, and then you'd get 5 square root of 2, and it requires more simplification. So let's go over here. It says, also, since x-intercepts are the solutions, you can technically graph the equations with the graphing calculator or app. Wherever the parabola intersects the x-axis are the solutions to the equation. So it says, let's graph y equals x squared minus 2x minus 3 on Desmos, which is the app I have right here on my tablet. So if I were to graph that one, if they ask me to solve this guy, and I graph it on my app right here, then I already know my answers are what? According to this graph, what are my answers? -1, +3. That's it. So if I know that, x equals -1 and +3. If we take a look at the next one on the Desmos app, here it is. If we were, obviously we know certain things just by looking at it. It opens down. We could find the vertex using the formula, but here's the graph of it. Now, guys, how many solutions does this one have? How many times does it cross the x-axis? 1. Where does it cross the x-axis? So what is the answer? The answer is -1, right? Now, the other graph had 2 answers. It had the negative, the negative answer and the positive answer. Right here, you only have 1 answer, and that one single answer is -1. So, x, on this one, x equals -1. Now, I know we're running out of time. Before we leave, if we look at this last one, it says graph y equals -x minus 2x minus 2. We already know it opens down, but if I were to graph it, check it out, guys, and I'm looking for the answers. If I'm looking for the answers, what would you say? Where does it cross the x-axis? It does not cross the x-axis. So it has no real answers. No real answers. You would say that the answers are imaginary. It does not have real answers. It does have imaginary answers, all right? But they're just not real, okay? So even graphing is not as good as the quadratic formula. The quadratic formula, you could find those imaginary answers. Graphing, you'd just be like, oh, it doesn't cross, so I can't find the real answers. But the quadratic formula, you will always be able to find the answers, even if they're not real. Let's continue down here. So as you can see with those previous 3 examples, sometimes parabolas really do have 2 answers when they cross twice. Sometimes parabolas only have 1 answer, or it crosses once or just touches once. Sometimes it has no real answers when it doesn't cross. So that's where the vocab word discriminant comes into play, and understanding the discriminant comes into play. So the value b squared minus 4ac inside the square root of the quadratic formula is called the discriminant. And its value will allow you to see how many solutions you will have. It should probably say how many real solutions you will have. So listen to this, guys. if b squared minus 4ac is greater than 0, what does that mean? If it's a positive value, then you will have two real answers. If your b squared minus 4ac is equal to 0, you're only going to have one real answer. If your b squared minus 4ac is less than 0, then you have no real answers. If it's negative, you're not going to have any real answers. Why is that? If it's negative, you're not going to have any real answers because, ladies and gentlemen, please stay with me. If b squared minus 4ac is negative and you're trying to do the square root of a negative number, that's imaginary. It's not real. So if your inside discriminant value is negative, you're not going to have any real answers. If your inside square root value, your discriminant value, is equal to 0, Gustavo, if you do b squared minus 4ac and that equals 0, then the square root of 0 is 0, and it doesn't matter if you add 0 to something or subtract 0 to something, it's going to be the same answer. It's not going to be two different answers. That is why when your discriminant is equal to 0, you only get one answer. Right? If I had 1 plus 0, and then I did 1 minus 0, it's still going to be 1. You get the same answer. So when the discriminant is 0, you only get one answer. When your discriminant is negative, you get no real answers. And of course, if your discriminant is positive, it doesn't matter what it is. If it's positive, you're going to get two real answers. And we do need to know that for the next homework assignment that we do. So keep that in mind. The discriminant tells you if you have real answers, two real answers, no real answers, or one real answer. We'll actually pick this up on the next video.